Hey, Michael Church, Crawl Space Ninja. Today I'm finishing up our Crawl Space Problem series. This is video number 5, and I hope you all have enjoyed this series that I put together for you. Been getting a lot of great comments and appreciate all of our YouTube comments. I try to answer all of those if I can. So if you have any questions or anything about what we've gone over, or maybe you have some suggestions for some new videos that you would like to see that maybe we haven't done or need to update, we'd sure appreciate you commenting down below and letting us know. So let's get started on Crawl Space video number 5, which is Crawl Space problem number 5, Crawl Space soil gases. Now, this is one of those topics I get a lot of pushback from depending on the company or the person I'm talking to. And I'll share with you a little bit about soil gases and ventilation. This is going to be kind of like your ventilation video. But one of the things I want to talk about is I'd rather ventilate from a source I know versus an unknown source. In other words, if I'm going to be pulling air from somewhere, I'd rather know where that air is coming from. So just keep that in mind. Most homes pull air from everywhere because they're not air sealed properly. And air sealing should be a part of ventilation. I know that sounds a little weird, but basically you want to air seal all of those bad areas. Like, for example, you don't want to be pulling air from a chase down from the attic or from, the garage or something like that. So the better you can air seal the home, the better you can ventilate the home, and that goes the same with the crawl space, okay? So let's get into this series, and first of all, I want to share with you that we have done 4 others. If you get a chance to check these out, the first one was about humidity, then we did standing water, then we covered insulation and air sealing, which you want to make sure you check out. That goes along with this video as well. And then, of course, mold and fungus was video number 4. All right, so crawl space soil gases. Soil gases can build up in your crawl space if it is not properly ventilated. And again, I get a lot of pushback about this, and I'm going to share with you in a few slides where my mentality of ventilating an encapsulated crawl space comes from. But just keep in mind that this is an important thing to do when properly encapsulating your crawl space. Ventilation has been used improperly for years. Fans have been used to control humidity. Fans do not control humidity. They can lower humidity. They can raise humidity depending on the source of the air that you're pulling from or pushing to. So keep that in mind. It's all about the makeup air, okay? A dehumidifier is how you control humidity if it's too high, and a humidifier is how you control humidity if it's too low. And as I've mentioned in video number 1, sometimes you need both. So if that's a concern, make sure you check out that video. Ventilation does not replace humidity control, okay? So just keep that in mind as well. I'm not talking about using a vent fan to control humidity in the crawl space. It's very rare that you can do something like that. And real quick, I want to make sure that if you are suffering from dirty sock syndrome, if you don't know what that is, don't worry about it. But I did a video about that. I thought that would be appropriate to mention. We'll put a link to that one down below if that's of interest to you. All right, so let's talk about EPA whole house ventilation systems. I'm going to put a link to this article. This is actually a pretty good article the EPA did about whole house ventilation systems. Basically, they talk about 4 different ways to ventilate a home: exhaust supply, balanced, and your ERVs and your HRVs, which is your energy recovery and your heat recovery ventilators. So I'm going to cover a little bit about what they had on their website for each of these, but as I mentioned, check out the link if you want to dive into this a little deeper. An exhaust, all right, exhausted ventilation. First of all, there's pros and cons to all 4. None of them are perfect. So if you're looking to ventilate the whole house, I just wanted to cover a little bit about this before I get specifically into the crawl spaces. Exhaust ventilation typically is the least expensive, works very well in cold climates. The cons are that it draws pollutants and moisture into the home. It relies on a lot of air leakage in order to work properly and can cause backdrafts. So in other words, if I've got a fan or something like that I'm pulling air to exhaust that air out, as they show here, I'm getting air infiltration through the walls, through the sill plate, through the band board or the rim joist, through the crawl space, through all of these areas, and none of these areas are being filtered, humidity controlled, or nothing. So it is the least expensive way to move air through your home. Also, you got to realize stack effect naturally moves air in this same manner. So even if this exhaust wasn't working, the stack effect would pull air from the crawl space to the living space out of the attic on a natural flow of air, which is called the stack effect. All right, so this is how most people ventilate. For example, turn on the bathroom fan. This is what happens, okay? So this is an exhaust fan. So I'm trying to move the odor out of the bathroom, out of the house. Well, as I do that, if you put your hand under the door of the bathroom, you'll feel that makeup air coming under that door to make up the air that's being pushed out of the bathroom from above. So that's just a good example and simple example of how airflow works, all right? Pros of supply ventilation are it's typically inexpensive, just like exhaust. It appears to be more simple to operate, better control than exhaust. In other words, you are actually determining where the air is going to come from versus an exhaust. Like in this slide, you're pushing the air out and the air is coming in through the air leaks. This one, you're actually bringing air in and you're still having air leaks, but you're pushing the air out. Okay, which can help because you're minimizing the outside pollutants. In other words, if I've got a filter right here, I'm actually lowering the pollutants that are coming in this pipe versus in this scenario, I'm doing nothing for the pollutants that are coming into my house from these areas, if that makes sense, okay? It also allows for you to dehumidify the air coming in. So if I've got a dehumidifier set up right here, like the new Aprilaire dehumidifier actually has a ventilation process, you can actually run an ERV and a dehumidifier or an HRV and a dehumidifier together to where that humidity is being controlled before it has a chance to make its way into the living space. And plus dehumidifiers that come with filters, so you're filtering and controlling humidity. All right, now keep in mind, some of these ventilators can open and close only whenever the humidity is not extreme outside, which means the dehumidifier does not have to work as hard, so you can control that as well. Some of these are smart enough to where you can set limitations on when they open and close and bring fresh air into the home, which is nice. And they'll typically work really well in hot and mixed climates. The cons are not great for cold climates because they tend to cause moisture problems through condensation and different things. And of course, they can increase your heating and cooling costs, especially if you're pulling in a lot of humid air trying to dehumidify it, whether it's at the source here or maybe down in the living space. So it can increase the heating and cooling costs. I would beg to differ that all ventilation increases heating and cooling costs in some way. So now let's look at a balance system. So what we're doing here is we're actually bringing in fresh air, bringing it in a controlled area, and then allowing it to exit in a controlled area. So that is what's called a balanced system, okay? It's good for all climates, all right? That's the pro. The cons are it's more costly than the first two I mentioned, more costly to install and operate, and can bring in moisture if you don't have some kind of humidity control going on, and obviously increases heating and cooling costs. So as this is showing, I'm bringing in a certain amount of air through this device. This could be a dehumidifier with a filter. Then I'm allowing that air to travel into the living space. As that air comes in, you can control however you want. You can have less CFM coming in than going out, or more CFM going out than coming in. But what they're trying to say is it's the same. So if you have 100 CFM going through the roof, you got 100 CFM coming in. And what that does is you can see we're eliminating air infiltration. Do you see how this is right here? I don't have these air infiltration marks as I did in the supply or the exhaust. So what the EPA is saying is that a balanced system is a better way to eliminate air infiltration. All right, now let's cover the fourth one, which is ERV and HRV, as I mentioned before. Pros: reduce heat, cool costs, cost effective in extreme climates. The cons are it could cost more than other solutions, even though it's reducing heating and cooling costs. It's a little bit more to install and maintain. may not be cost effective in a mild climate, which is interesting. So it's better in your extreme hot and cold climates, not that good in a mild climate. It does require freeze and frost protection in cold climates, as well as it does require more maintenance in most cases. Now, I do want to let everybody know that we do have the April Air ERV on our DIY store if you're interested in looking at one of these great products. I put a link to that, as well as on that same link, there is a link to a PDF about how energy recovery ventilators work. If you want to learn more about the ERV, I recommend you check that out. And I believe we did a video about ERV versus HRV. If you do Crawl Space Ninja ERV versus HRV on YouTube, you should be able to find that video as well. Now, let's get into more crawl space specific information about ventilation and soil gases. And just a quick plug, if you haven't checked out my book, Crawl Space Repair Myths Busted, I encourage you to do that. I cover a lot of different ventilation myths and different things like that in that book. I encourage you to get that. I'm going to share one of the myths that I talk about in the book a little later in the video. But some soil contaminants, remember, everybody talks about radon. All right, radon's a big deal, I get it. #2 cause of lung cancer in the US, #1 cause of lung cancer amongst non-smokers. It is a huge problem, but it overshadows the other soil gases that are also found throughout our environment. Your pesticides, your petroleum products, your methanes, your hydrogen sulfides, your asbestoses, your lead, your chromated copper arsenics, which are your CCAs, and your creosotes. I got a chat from one of our franchises that someone sprayed creosote on the subfloor of a home. Man, that's a bad mistake. Don't ever spray creosote on the wood of your house. It's impossible to get rid of. It off gases. It's got all kinds of issues with it. I remember I was running around along railroad tracks. I know you're not supposed to do that, with my dog, and they actually got into some creosote and their muzzle like swelled up, and it freaked me out. So there's some issues with these things. Obviously, it's all about moderation, but let me tell you a little bit. First of all, methane. High levels of methane can reduce the amount of oxygen breathed from the air. This can result in mood changes, slurred speech, vision problems, memory loss, nausea, vomiting, facial flushing, and headaches. Okay, so radon's bad, methane's bad. Hydrogen sulfide. At low levels, hydrogen sulfide causes irritation of the eyes, nose, and throat, moderate vomiting, as well as coughing. Moderate levels can cause headaches, dizziness, nausea, and vomiting, as well as coughing and difficulty in breathing. Higher levels can cause shock, convulsion, coma, and death. And finally, creosote. And I wanted to do this one because of the homeowner that had creosote sprayed all over their floor and subfloor. These reports indicate that brief exposure to large amounts of coal tar creosote may result in a rash or severe irritation of the skin, chemical burns of the surfaces of the eye, convulsions, and mental confusion, kidney or liver problems, unconsciousness, or even death. Okay, so all of these, according to the research that I've done, have been found in soils. Now, that doesn't mean you have all of them, but all of these are soil problems. Imagine how long it's been prior to your home being built. You don't know if you were in some industrial area or some chemical. I mean, the records only go back so far, so you don't know what was going on at that house. So ventilation is super important to make sure you're drawing all of that bad air out of the crawl space. And this is what I wanted to get to right here. The EPA, what the EPA says. Now, all of my crawl space ventilation research and everything started right here, which is the EPA's Indoor Air Plus program for insulated and conditioned crawl spaces. All right, so I wanted to show you this slide. This is why I am such a proponent of ventilation. As you can see right here, 1 CFM for every 50 square feet of floor space should be ventilated in a crawl space. We still adhere to that today. Section 1.4 of the Indoor Air Plus program says sealed crawl spaces and basement perimeter walls to prevent outside air infiltration. So in other words, I did a video about this, video number 3, I believe, about air sealing and insulation. Check that out. Insulate crawl space and basement perimeter walls according to the prescription values determined by local code, or R5, whichever is greater. Typically R10 is recommended in most codes, if not higher. Provide conditioned air at a rate not less than 1 CFM of air for every 50 square feet of crawl space to the floor area. So in other words, you could do 2 CFM for every 50 square feet, 3 CFM. They just don't want you to do less than 1. All right. And what that does, however, if a radon resistant features are required, see specifications 2.1, do not use the crawl space exhaust method. So if you have been tested for radon and found that your home has high levels of radon, they don't recommend this as a way as a radon mitigation system. They recommend you install a radon mitigation system. But if we're talking about just basic soil gases, you want to do a rate of no minimum or no less than 1 CFM of air for every 50 square feet. The Lamanco PCV1 fan, for example, does a 5,500 square foot crawl space, or up to a 5,500 square foot crawl space based on that formula. It's okay to go higher on the CFM. So in other words, if your crawl space is 300 square feet, a 100 CFM fan is okay versus having it too small. So you can't oversize the CFM according to them, but I do believe that you can pull too much air out of the crawl space to where you're losing too much energy, you have too much energy loss, and perhaps even pulling too much dry air out of the crawl space. So I like the 1 CFM for every 50 square feet for a sealed crawl space. If you are interested in doing radon testing, there's some great radon DIY test kits available. These are a couple that I've found over the years. The Air Things product seems to do very well. It's got great reviews. I'm going to put some links down to these radon testing meters down below. But they are great for DIY testing. Remember, anything under 4 picocuries or 0.4 picocuries is recommended. So if it's 0.4, it's considered too much. It has to be under 0.4 in order to be okay. And the EPA says the lower the better. They really want it 2 or less, but you know, it's like cigarette smoke. None is best, but none is not achievable if you live in a house with a smoker. If you got radon, none is unachievable, so you want to get it as less as possible. Radon levels fluctuate. Keep that in mind as well. So depending on when you test, you could see some fluctuations. High winds, rain and storms, snow and ice and cold temperatures, windows and doors being open. Obviously, if you're running a radon test and you go open all the windows, probably not going to have an accurate measure. The closer it is to the ground, the more likely it's going to be high, but you don't put radon tests in crawl spaces that are ventilated or sealed, okay? I did a great video with the gentleman from Kansas State University. So what you want to do is you want to test the living space. So if you have a basement that is finished that you live in, you would test it there. If you have an unfinished basement that's not conditioned, you would not test it there, for example. Make sure that your HVAC is not running in most cases for the test, but that's kind of a hard thing to do, especially if these tests require 24 hours, but that can also throw off the test. Presence of proper air sealing can also throw off the test. So if you're running your bathroom fans, for example, it's going to mess up the test. Radon mitigation, quick brief overview. I did quite a few videos about this. Check out, can radon fans control moisture? Because I've had a lot of people ask me that question. It's a video for you to look at, but this is a great example of radon mitigation installed. As you can see, this is in addition to the Indoor Air Plus that I talked about the 1 CFM for every 50 square feet. You may have a basement that requires radon and want to take it up through the attic or whatever. So this is a radon mitigation installed properly in most cases. You don't want this window being here if you've got radon spewing out right here. So if you had a window here, you would want it to go up above the roof line as they did on these areas over here. Soil gas myth. You'll be able to detect a strange smell if radon is present. Radon is naturally occurring radioactive gas that has been deemed to be hazardous to human health. And since it is tasteless, colorless, and odorless, it is impossible to detect without specialized equipment. So if someone's telling you you can smell radon, not the case. As I mentioned, my book covers a lot of the myths talked about in ventilating a crawl space, so I encourage you to check it out. And also, one last thing I want to say, I hope you liked this series of videos that we did. I appreciate you sticking with me on these videos. Hopefully they were very helpful. Please share these with people, even if it's your realtors, your neighbors, your home inspectors, your local contractors. We'd love it if you'd share these video series with them. And of course, we hope you'll share our YouTube channel with everybody. Like and subscribe to our YouTube channel. I am Michael Church, Crawl Space Ninja. Hope you like this. Hope you make it a happy and blessed day. And we'll see you later.